We are going to look at exponent rules. We're going to start with the problem 3 squared. What does 3 squared mean? Well, 3 squared means 3 times 3. It means 2 threes, or 3 times itself twice, which is 9. So let's start by looking at exponents with patterns, and we're going to look for rules today of exponents. So fill in the following. 2 to the first power is just 1 2. 2 squared is 2 times 2, which is 4. 2 to the third is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 to the fourth is 2 times 2 times 2 times 2, which is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And we have 2 to the fifth, which means 5 2's multiplied by each other. 2 times 2 times 2 times 2, which would be 16 times 2, or 32. So, looking at this pattern, look at how they go up. 2 to 4 to 8 to 16 to 32. Think about what's happening every time. What are we multiplying by each time? Well, we're multiplying by 2. So let's use that fact to work backwards. So now we're on this side right here. I'm just going to write in the answers right here. So 2 to the fourth was 16. 2 to the third was 8. 2 squared was 4. 2 to the first was 2. So remember what we did here is we multiplied by 2 by an extra 2 every time to get the next answer. So what if we worked backwards? What is 2 to the 0 power? Well, instead of multiplying by 2, let's say we go backwards. Let's divide by 2. 2 divided by 2 is 1. So 2 to the 0 power is 1. What's 2 to the negative 1? Again, let's work backwards. Let's divide by 2, and that's 1/2. What's 2 to the negative 2? Well, again, let's divide by 2, and that would be 1/4. So we're going to take a look at these things right here, and there's more than one way to come up with the answer for 2 to the negative 2, or 2 to the negative 1, or 2 to the 0, and we'll explore those in the next few days. Learning target today, explore 2 rules of exponents. There's something called the product rule and the quotient rule, and we're going to try to find shortcuts to solving those. So the directions for each problem: expand the exponents and look for a pattern or shortcut to finding the answer, and then we're going to talk about the shortcut. So the first one is the product rule. Product meaning multiply. Product is the answer when you multiply. Okay, so let's write it out first. Expand it. 3 squared is 3 times 3. 3 to the fifth is 3 times 3 times 3 times 3 times 3. Well, how can we rewrite that? 1, 2, 3, 4, 5, 6, 7. This is 3 to the 7th. Let's do that again. 5 to the first power is just 5. And then we have 5 to the third power. So if we rewrite this, this is 5 to the fourth. Let's try it when the base, and the base is the big number, and the exponent is the little number. So here the base is x, and we have 5 of them. And then we have 4 of them. So if we count how many x's we have x to the 9th power. Here the base is 7, the exponent is 10. So I could write out 10 of these. I'm not going to put a dot in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 more. So this is 7 to the 12th. So we're looking for a shortcut. In other words, how can we skip the expanding part? How can we go right from the expression to its simplified form? So that's what we're looking for. What is the pattern? Now, if you notice that they have the same base, if we look at the exponents, we can add them to get the answer. 2 plus 5 is 7. 1 plus 3 is 4. 5 plus 4 is 9. And 10 plus 2 is 12. So let's generalize this rule. Look for a pattern. When 2 exponents have the same base, or the bottom number, what can you do with the exponents? What's the shortcut instead of expanding? Well, you can add the exponents. So the general rule, so if we change all our numbers to letters and say m and n can be any number, Then if it's a to the m times a to the n, this is the same as a to the m plus n. Add the exponents. So the product rule means when they're being multiplied and they have the same base, add the exponents. Let's look at another rule. The quotient rule. Quotient means division. Expand the exponents and reduce. Look for a pattern or shortcut to finding the answer. So this is 4 to the 5th power. I'm going to put 5 4s on top. I'm going to put 2 4s on bottom. What is any number divided by itself? Well, it's 1. So let's cancel the 1s here. And when we do that, we have 4 to the 3rd power left. Let's do it again. Let's do 8 x's on top. 6, 7, 8. And we have 6 x's on the bottom. Again, let's cancel the 1s. We can cancel 1x over 1x. It becomes 1. And when we do that, we have x squared left on top. So we're looking for a shortcut here. What can we do with the 5 and the 2 to get the 3? What can we do with the 8 and the 6 to get the 2? Let's do a few more and see if we can generalize. 7 to the 4th means 4 7s on top. 7 to the 3rd. So we're going to cancel, and we're left with 7 to the 1st power, which we can just leave as 7. I'll put a 1 here. How about this? A to the 11th. I think that's 11, and over a to the 9th. Let's cancel here. And we have a squared. So again, the question is, how do we take these numbers here, skip the expanding, and get the answer? Look for a pattern. When two exponents have the same base, what can you do with the exponents? What's the shortcut of instead of expanding? Well, you can subtract the exponents. So to generalize the rule, when it has the same base, this is a to the m power minus n. So you can subtract the top exponent minus the bottom and get the answer. What if the exponent is larger on the bottom? Okay, so now we're going to fill in this table right here. I wonder if I can make this a little bit smaller here. Okay, we can kind of fit this here. Okay, expand and reduce. So we have 5, 2 5s, we have 6 5s. Let's cancel some stuff here. And we get 1 over 5 to the 4th. But using the quotient rule where we subtract, this is 2 minus 6, which would be 5 to the negative 4th. Let's do another one. Let's say we had 3 x's on top and 5 on the bottom. Let's cancel the 1s. And we get 1 over x squared. But using the quotient rule, 3 minus 5 is negative 2. All right, let's do this one right here. If we have 14, we have 4 14s on the top. We have 7 of them on the bottom. 1, 2, 3, 4, 5, 6, 7. We cancel. We have 3 14s on the bottom. But using the quotient rule, 4 minus 7, we get 14 to the negative 3. Okay, how about the next one? If you have 2 b's on top and 8 on bottom, and if you cancel, how many are left and where? Well, there's going to be 6 b's on the bottom. But according to the quotient rule, this is b to the negative 6. The next one, 1x on top, 3 on bottom. 1 cancels with 1, we get 1 over x squared. But that equals x to the negative 2. So we're looking at equivalent expressions. These two actually are the same thing right here. They mean the same thing. It's just a different way of writing it. So if you have a negative exponent and you flip it, if it's negative on top and you flip it to the bottom, it becomes positive. So again, if you have a negative exponent on the top of your fraction, and these are all over 1, and you flip it to the bottom, it becomes positive. And it comes from canceling the 1s and figuring out how many are left. So let's do the last one here and then generalize. So thinking about canceling, if you have 20 hundreds on top and 25 on the bottom, when you cancel, how many are left and where? Well, we would have 5 100 less on the bottom, and that's equivalent to 100 to the negative fifth power if we use the quotient rule, 20 minus 25. So to generalize, if it's negative, I should write it right here. If we have a to the negative n, that equals, let's write this better, 1 over a to the n. And it goes both ways. Okay, so I guess I could have put that here. So again, if it's positive on the bottom, you can flip it to the top and make it negative. And if it's negative on bottom, you can flip it to the top and make it positive as well. So that's what the bottom talks about here. You can do the same thing if there's a negative exponent. So if you have x to the negative 3, that's the same as 1 over x to the third. P to the negative 2, flip that to the bottom. Q to the negative 7, flip that to the top. So if it's negative, flip it. It's the flippy rule. Okay, so now let's use those 3 rules we looked at today, quotient, product, and the flippy rule, and simplify. So here the base is 19. They're being multiplied. We're going to add the exponents. Here, think about canceling. If you have 7 x's on top, or b's on top and 4 on bottom, when you cancel, how many are left and where? There's 3 b's on the top, or 7 minus 4 is 3. Take a look at this. We have 2 bases. Let's look at the a's first. 5 a's and 3 a's, there's 8 a's. Then take a look at the b's. 7 b's and 10 b's, there's 17 of them. Let's look at the h's. There's 8 on top, 2 on bottom. When you cancel, how many are left and where? There's 6 of them on the top. So this is h to the 6th. When you cancel the j's, you can cancel from 1 on top and bottom, so there's 6 j's on the bottom. And let's take a look at the last 2, and this is what you'll be practicing today, just these 3 rules here. And then we'll do a few more tomorrow, rules of exponents. Okay, so here you have 2 numbers, 2 and 6, and they're different bases, but it's being multiplied, so we can multiply those together. 2 times 6 is 12. There's d to the 7th and d to the 11th, so if you write them all out and you were to add them up, you would have d to the 18th. So here's your final answer. We have 3 different bases here. We have the 10s and the 5, the numbers, and the x's and a y here. So let's take a look at this. First I'm going to simplify the bottom. We have 10 over 5, x to the 12th, y squared. And the x's here, I'm going to combine those. This will be 19 x's. Okay, so now let's separate the problem. Let's do the numbers first. What's 10 divided by 5? It's 2. Then let's take a look at the x's. You have 12 on top and 19 on bottom. So when you cancel, how many are left and where? There's 7 x's left on bottom. If you were to write them all out, cross them off. 7 left on bottom. And then you have that y squared, which doesn't change at all because there's no other y's. So today practice these rules, and we'll practice them again tomorrow until we're comfortable with our rules of exponents.